Here we are at example 5 from our 1.4 number 2 set of notes. We're asked to determine where is this function continuous. And we notice that it's pretty vague with just an a and a b value. We don't even really have some y values. Here is that function. And yeah, we're just kind of told, where is this thing continuous? Well, just kind of looking at our image, we see that we're not really including this a value point because we do see a jump there. And so I'm kind of leaning to believe that we would not include that a value, so we're going to have a parenthesis around him. And then he does go onwards towards this b value. It does look like b is included. So we have b being included. And as a result, this is what I'm kind of leaning towards for where things are kind of continuous. But now we have to use our three-step criteria for proving continuity. So let's just look at this endpoint a and see what's going on there. For the first one, is the function defined at a? In other words, is there a point there at a? Well, yes, there is. So we do see that it does meet our first criteria. It does exist. Criteria 2, the limit as x approaches a of our function f of x. And we have to specifically say a from the right side, because there's really no left side to this guy. Does that exist? And the answer to this is yes, it does in fact exist. You can see it is approaching a limit from the right side. And then criteria 3 simply says, do these in fact match up? Well, this is really where we start to see things take that turn. As we can see, as you approach a from the right side, that limit, it is not equal to our function when we throw a inside of it. Here's that point. So as a result, we can say definitively then that a is not included inside of this continuous interval. Now looking at b. For our first criteria, is it in fact defined? Well, is f of b defined here? Yes, it is. It does exist. You can see it definitively right here as a point. 2, the limit as x approaches b from the left side, because again we're approaching b from the left, of our function, does that exist? Well, yes, it does. We don't really see any vertical asymptotes, so we're okay there. Step 3, do they in fact match up? Is the limit as x approaches b from the left of our function, does it in fact equal f of b? And we can see right here that in fact the limit as you approach b from the left is equal to that point, so it does satisfy criteria 3. So it satisfied 1, 2, and 3. And as a result, because it's satisfying all 3 of these criteria, we would then include b for that continuity. So we would have that bracket there. So this guy did not work out. So again, though, this is a really great example that kind of illustrates that whole idea of, do you include endpoints, and if so, where? Well, it still has to satisfy those 3-step criteria for continuity. But it is in fact okay where we have these one-side limits, because there's only one side really to it. There's not this other side. And that's okay when we're just specifically talking about including endpoints or not. So again, though, that is example 5 from our 1.4 number 2 set of notes.